Hello everybody, Dr. Burns here with our first lesson in Chapter 1 of General Chemistry 1. So welcome to your first lesson in chemistry. Our first lesson is going to focus on sections 1, 5, and 6 of Chapter 1 of our textbook, where we're going to learn about the study of chemistry, classification of matter, and the properties of matter. So let's start and talk about how chemistry is the central science. Chemistry is interconnected to many different STEM disciplines. At Western, it is required by 38 majors on our campus to take General Chemistry 1. So here I have a little web of how chemistry relates to all of the STEM disciplines. And this is only showing some, not all of them. But I bet if you look at this web of connection, you will find your major or what you want to do when you graduate college, because chemistry relates to everything. Chemistry relates to so many things in our life. For chemistry in everyday life, we see this all the time. For example, when we have to cook food or when we're eating that food and digesting it, that's chemistry. If we're driving our cars and using oil in order to make gasoline, we need the gasoline to drive our cars. That's chemistry. Even the act of using an engine in the car, that's a type of chemistry. We won't learn about that this semester, but you'll learn about it in general chemistry too. Things like the polymers that make up our clothing and the cookware that we use to cook the food and do chemistry there, that all utilizes chemistry. Any sort of medicine that we take, that is a form of chemistry because those are compounds, those are chemical compounds that are in the medications that we're taking. And I put this one on here because it is summer, at least where I'm at right now, and sunscreen is a major use of chemistry in blocking out UV rays. So overall, chemistry is the study of the composition, properties, and interactions of matter. Now, what is matter? Well, matter is anything that has mass and occupies space. Now, chemistry has been around for many, many years, with attempts to understand the behavior of matter extending back to more than 2,500 years. Okay, so the Greeks, that's where they discovered the four elements, earth, air, fire, and water. And alchemists, way back when, attempted to transform metals into noble metals, and that's how they were able to start making medicines, way back before we had chemistry textbooks that could tell us exactly what to do. Now, in order for chemistry and science overall to grow from way back when, thousands of years prior to this to now, to where we are now, in order to make those scientific discoveries that we are all very accustomed to and know much about, scientists have to use the scientific method. As chemists, we can't just say, oh, I know this, or oh, I know that, just because we thought about it in our heads. We have to prove it. We have to prove it through testing, through hypothesis, through showing data over and over and over in order to prove what we are saying. So, science is based on observation and experimentation. And what that scientific method plans to do is to answer questions and to explain observations in terms of the theory of chemistry. But as we all know, there's no single route to doing that, to solving a problem, to figuring out the answer to a question. We all know there are many different ways to do that. And that's why we formulate a hypothesis. We think, oh, will this happen? Let me test it out. That is a hypothesis. A hypothesis is a tentative explanation of an observation, and then we test that hypothesis through experimentation, calculation, and comparison. Now, if you're in Chem 1100, you may also be taking General Chemistry 1 Lab, Chem 1110, where you will be doing this. You formulate a hypothesis, you experiment, you do calculations, you compare different trials that you do in those lab experiments in order to prove or disprove your hypothesis. Now, in the labs, like how we see in chemistry labs at college campuses, we never really have enough time to test that hypothesis enough to say if we can truly prove it or disprove it, because you have to do these experiments over and over and over so many times, changing different variables in order to prove that hypothesis. But once a hypothesis is proven, or if it's still being sought after, we then take what was learned and we classify it as either a law of science or a scientific theory. A law of science summarizes many experimental observations and describes a portion of our natural world. So laws of science are usually things that have been studied for many, many years. We're talking tens of hundreds of years by multiple different scientists all around the world. A scientific theory is something that still has to be proven, but it has testable explanations of a certain aspect of nature. The scientific method can be outlined through this outline here. So we start with an observation. Something. We see something and we have a general curiosity of why that thing is happening. Why does the sun go down at the end of the day? Why does my steak cook when I put it on the grill? What is actually happening? I have an observation and a general curiosity as to why that observation is occurring. Now, in order to then take that observation and curiosity, what we're going to do is form a hypothesis and make some sort of prediction as to what the outcome could be. What could that result show us and prove about our natural world? So once we have a hypothesis that is formed, we are going to perform an experiment. And this roundabout here is going to always take the longest amount of time. We form a hypothesis, we make a prediction, and then we perform our experiments. And from those experiments, we can make additional observations. And sometimes those experiments, the results, the calculations, and the additional observations that we see, sometimes are not consistent with our original prediction. So what we have to do is go back and reform our hypothesis with our newfound knowledge of that observation that we saw. So we're taking our initial observation and general curiosity, and now we're learning more about it so that we can change our hypothesis to hopefully make more sense of what comes out of it. So we go around this loop many, many times. Scientists go through this loop many times, usually each time changing a variable with each new test that they're going to do. And at some point, they come out of this loop and finally see that their results are consistent with their prediction. And in order to say that our results are consistent with our prediction, we need to have some really good data that can be reproduced multiple times in order to say that. It can't just say it's not going to happen after one experiment. Unfortunately, that is not how we do science. Okay? But once our results are consistent with our prediction, then those results, that knowledge, that newfound knowledge, contributes to the body of knowledge overall. And what people do then is they test it themselves. The other chemists, other scientists test those hypotheses and try to either prove it or disprove it. So sometimes we see that after we contribute to the body of knowledge, we go back and we have to do further testing because another scientist found a way to disprove that hypothesis. So we may have to go backwards and do our loop again. But over time, we're going to continuously come back to our contributions to the body of knowledge, and then that information either becomes a law or a theory of science.